Never have found it. Okay, let's go with our first question. I'm just going to go, let me sort it by, I don't know if I should sort it by, I'll try to sort it, go away. All right, 2.1, 2.2, I think we went over, I don't know where she is this morning. And that's another class. See, that's what I'm saying, it's not working right. It's sending me other classes. That's 109. I'll just go with dates. All right, this one is 2.3, number 4. Number 4. Okay, it says, use the transformations of graphs to sketch the graph of y sub 1, y sub 2, and y sub 3. Check by graphing in an appropriate viewing window of a calculator. Well, we're going to do it by hand. Okay? And the reason I want to do it by hand is because I could teach my 7-year-old how to use a calculator. I don't care about you using a calculator because, hey, gum. She did bite into it. I'm just kidding. We're going to do it by hand. So what I want you to do, and the reason I want you to do it by hand is because you understand it better when you do it by hand. I want you to take a piece of paper, and I want you to divide into, or not divide it, I want you to turn it into one big graph. Graphing paper would be great if you had it, considering we are graphing. But and straight edge would be good too. Dang old ID, dang old credit card, and number it. Now, before we do these, what is the parent graph of these functions? What's the parent graph? Remember us drawing those 6 graphs with the parabola? All right. So what I want you to do is, before you even start doing this, I want you to graph f of x is equal to x squared in black, or pencil, or black pen, something very basic. All right? Pencil, black pen, something dark. And you might want to get your highlighters out if you got some, or colored pens, or colored pencils, because you're going to be using them. So on this graph, I want you to graph f of x is equal to x squared. And we're going to do it on here too. I did this with my Math 109 class yesterday. So I'm going to change to my white paper, and we're going to turn the grid on. I know, y'all are impressed. I don't think I knew how to do this, did you? I amaze y'all. Amaze myself too. Alrighty. Now x squared is pretty easy to do, right? 0, 0. Let me change that to red. No, well, got to change it to black. 0, 0. What's 1 squared? 1, Hubert. Thank you, class. What's negative 1 squared? 1, Hubert. Thank you, class. What's 2 squared? 2 squared is 4. What's negative 2 squared? 4. Positive 4. It's negative 2 quantity squared. It turns into a positive. How about 3? What does 3 turn into? 4, 5, 6, 7, 8, 9. And 3 and 9. Negative 3 and 9. So, just using mental math, you should be able to do this without any problem. No, don't want that color. All right, so there's your parent graph. There is what you're going to compare everything to. Now let's go back to our handy-dandy question. All right, graph this one. X squared minus 2. X squared minus 2. Now how do you graph it? Well, you do the same thing you did back in pre-algebra. You take your handy-dandy graph or chart. And you put, I always use unless it's a fraction, I always use -2, -2, -1, 0, 1, and 2. I always use those unless it's a fraction. Now our function is what? X squared minus what? Ooh. F of x what? X squared minus 2. Are y'all awake? Are y'all like responsive? You know, words come out of your mouth. Yes, no. That would help me out a little bit. Okay? What's -2 quantity squared? Minus 2. -1 squared is 1 minus 2. 0 minus 2. 1 minus 2. 2 squared is 4 minus 2. So there is our points. So we're going to graph those points. -2 and 2. -2 and 2. I'm going to do this in red. Sorry. Need to do this in red. Or some other color. Really? All right, we're going to do this one in red. So -2, +2, -2, +2. And the next one is -1. 1. That's supposed to be a -1. -1 squared minus 7. That's supposed to be a -1. -1 and -1. 0, -2. 1 and -1. And 2, +2. So what happened to our our parent graph? Shifted down to. Why? Why did it shift down to?
Because of the -2 is the function.
Because the -2. Now a lot of people say, well, Hubert, how do you know that's not a vertical shift? I mean a horizontal shift. The horizontal shift will always be inside the square. Remember that. On your sheet. Where is that sheet? Just pull out that sheet that we did the forms, and we highlighted A, and we highlighted H and K. Remember that? You need to put a note on that if we didn't that day. I don't know if we did. Somebody got your notes dated. Need to date your notes. Always date your notes. There it is. Do I have on there anywhere X? If X is attached to the other number, then it is a horizontal shift. This one's not attached to X. It's attached to what? X what? X squared. If it was attached to X, it would be X plus 3, what? Quantity squared. So you need to make a note of that. H has to be attached to X within the function, within the X function. or within the absolute value, or within the radical. All right? Now look at this one. Something's going on with this one. We got a 1/4 x squared. Well, that's not 1/4. That's 1 what? That's 1/16 x squared. I don't know why they did that. I guess to irritate you. I don't know. But anyway, let's do this one. 1/16 x squared minus 2. What's that 1/16 going to do to your parabola? It's going to make it wider because it's a wrench size, 1/16. Although the smallest wrench size I've seen is 1/4. But anyway.
Where are you getting 16 from?
It's squared. The whole thing's squared. 1/4 x is quantity squared. 1/4 squared is what? 16. They're trying to trick you here. They're trying to get you to graph 1/4 x squared. It's not. It's 1/16. What if they just had the square with the x? Then it would be 1/4 x squared. They're trying to trick you. So graph that one. Graph it in blue. We'll do that one in blue or another color, whatever you have, so you can see the difference on the graph. I'll write it 1/16 x squared minus 2. 1/16 x squared minus 2. Let me go. Okay, I'm going to use different numbers because it's a. I'm going to use different numbers because it's a fraction. One six. I can't do anything right this morning. 1/16 x squared minus 2. So I'm going to use negative 32. Oh, no, I'm not going to use negative 32. We can use negative 2 because, no, that would give us another fraction. We can use 4. Yeah, 4 will work. 4 and 8. Negative 8. Negative 8, negative 4, 0, 4, and 8. Why did I use those numbers? Give you whole numbers. It cancels out the fraction. And I tell all my 110 students and all my 102 students, whenever you have a fraction, you always use multiples of the what? Denominator. Now, a lot of you say, well, 16 won't go into 8. No, it won't. But 16 will go into 8 squared. So what's negative 8 squared? And what's 64 divided by 16? 4. And what's 4 minus 2? See how easy that is? Negative 4 squared, 16, 16, 1, 1 minus 2, 0 minus 2, 4 is 16. 4 is 16, 1 minus 2, 8 is 64, it'll be 4 minus 2. Would that be negative 2? Something ain't right. These two should be the same as these two, that's right. I guess it's right.
With the negative though, wouldn't you want to be positive?
We'll just see what happens. Let's see what happens. Negative 8. Negative 2, negative 8, 1, 2, 3, 4, 5, 6, 7, 8, and negative 2, positive 2, positive 2, negative 4, negative 1, negative 1, 0, -2. 4, -1. It's going to look right. 1, 2, 3, 4, -1. And 8, +2. 4, 5, 6, 7, 8. How does that look? Looks like a satellite dish. Old satellite dish. Let's see, we're going to go here. We're going to go here, change it to blue. Okay, what can we tell happened here with this parabola? What happened to it? Got wider. Did the vertical shift change? No, it did not. And that's why it's still crossing the y-axis at the same spot.
So when we like get into our computer, when it graphs it, would we, like, what number, like, it asks for the horizontal stretch and the vertical stretch, and then it asks for the shifts. So how would you put it in there to make it look like?
The horizontal stretch will be 1/16,
Okay.
because that's A.
Okay.
And your vertical shift is negative what? 2.
The one.
Yeah, right there, H. All right, now, everybody's feeling good about themselves? You try the last one. It's black. Where's my knife? They wouldn't give you an extra knife.
They didn't put a knife in there for the letter?
I guess they didn't. That's okay. Motto of the Marine Corps: adapt and overcome. I think I can handle this.
I have a knife in my purse. Probably don't-
That's all right. I don't know who you stabbed. What is this really? (16x² - 2). So I'm going to do this one in orange. You can do it in whatever color you got left.
You have a work email.
We're going back with my negative 2, negative 1, 0, 1, and 2. Negative 2, negative 1, 0, 1, and 2. And we have what? 16x squared minus what? 2. And I'm going to tell you, you're going to get some big numbers. So some of them you're not going to be able to graph. So negative 2 squared is 4. That's 64 minus 2 is 62. Negative 1 squared is what? 1. 1 times 16. 16 minus 2 is 14. 0, negative 2. 1 is 14. And 2 is 62. So you may have to put a 0.5 in here to get a smaller number. Or, you know, you can do what you want. But 1/2 squared and 1/2. What's 1/2 squared? 1/4. What's 16 over 4? 4 minus 2? 2. So at 1/2 you get a 2. And at 1/2 you get a 2. So now let's plot those points and let's see what we get. So, negative 1 and 14. Let's try. Negative 1 and 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's up there somewhere. That's not going to help us. Negative 1/2 and positive 2. Negative 1/2. Hold on a second. Negative 1/2 and positive 2. 0, negative 2. 1/2, positive 2. And of course, 14, I'm going to just put it, instead, let's say negative 1 and 14. I'm just going to put it up here. That's 14 for y'all, okay? I'm just doing that just so you can see what it does. And we'll color our line orange. And what does that do to your graph? It starts with a C. Compresses. Stretch, compress.
So I have to put that in
You put 16.
the,
What does it say?
that the number is greater than
Well, I hate it. Or I guess 1 or 4. Put in 4.
Put on a vertical stretch or horizontal stretch?
The horizontal stretch, because that's a horizontal stretch. Well, it could be a vertical stretch. You could say vertical stretch. You could do this. So that would be a vertical stretch. You could say a vertical stretch of 4, or horizontal compressment, or horizontal compress of 4. Actually, it's 16. I don't know why they won't take 16, but
either way.
well, what is the question asking?
I mean, it's the same thing, it's just,
This is annoying to punch it in. You can't punch in the numbers. You have to put in the number for like stretch or something.
yeah, like you can't just graph it. Like it.
Well, I don't know how you would even do that. Okay, well, I won't give you those on the test. I will give you problems. The problems I'll give you is match the graph with the equation. That's the ones I'll give you. So I'll give you 4 graphs over here, and I'll say which one is this equation. That's
What do
what
you
I'll
want
do.
us to do about our homework then?
Just try to do the best you can. Now I'll look. I'm going to do it here in just a minute and see what it says. Okay, everybody good? Now you see why I make people do it by hand, because you can actually see what's going on. And that's the best way, and I've been teaching for close to 20 years now, and that's the best way that I've seen to show students the vertical and horizontal shift. And I don't get into the compression that much. I just tell you that this is compression and this is stretching. Now, if I do it this way, what did we do to the blue one along the y-axis? We compressed it. What did we do to the orange one on the y-axis? We stretched it. So it's you gotta in which origin are you talking about? Are you talking about the y-axis or are you talking about the x-axis? So you have to watch the question to see what the question is asking. Is it talking about the x-axis or is it talking about the y-axis? Okay, so let's see what the question's asking, and then I can see what you're talking about, Mrs. Ugg. Yeah, I'd leave too. Just get mad. All right. Says use the transformation. Check by graphing the appropriate. So I guess we graph this one first. So the first one's -2. Oh, and you move it over? Do you move it?
No, you have to put in the numbers into the sections. Like for the
Okay.
first one, you would put -2 on vertical shift.
Okay.
And basically, what I just figured out is you just have to go in and put the numbers like where they belong. So you wouldn't put 1/16, you would put 1/4 in the horizontal stretch.
That's real stretch.
Oh, vertical stretch. Okay, so it's got a horizontal stretch. Shut up and leave me alone.
I told you it's annoying.
Yeah, it's annoying. It's very annoying. I wouldn't do this on the test.
So-
I've never seen this question before. I've never seen this layout. This must be new. Horizontal stretch would be 1.
Or, yeah. So then it's-
Vertical shift is -2. And horizontal shift, and that would be your answer. I don't know what they're talking about.
We have to graph all of them.
Okay, well, just do the best you can on the homework. Do the best you can, but I'm not going to give you that on the test. I'll show you what mine will look like when we get there. Let's pull up another question. Does that help you, whoever sent that one? Does that help? Okay, let's try nerding. It's already logged me out. Maybe one day Tri-County Tech will catch up with the 21st century and teachers will be using the internet more and won't have to log out every 5 seconds. I don't know, we still got teachers writing their emails in the subject line. Yeah. Pitiful. All right, this is 2.1, number 22. 2.1, number 22. Determine whether the graph is a function symmetric with respect to. All right, write that one down. Well, that could be a test question. I know.
I got to write that yesterday.
Good for you. Forest College is accepting and Tri-County is accepting.
Isn't that scary though?
Yep.
It's so like it terrifies me. What number is it?
I don't know. I done called it out. I'll get to it in a second. So we've got to check to see if f of negative x is equal to f of x. And then we got to check to see if f of negative x is equal to negative f of x. That's what you got to do. So, when you're checking symmetry, first you check to see if f of negative x is equal to f of x. And then you check to see if f of negative x is equal to negative f of x. So let's go ahead and see. And the number of this one, did y'all write down what number it was?
2.1 and 22.
Thank you. All right, so let's pull up our handy dandy. Everything back to normal. So we know f of x. Is that black? I don't know, it looks black. It's too wide. I don't know if black keeps going to that. Hardest thing to change on this thing is the width of the pen. F of x, see, is equal to x to the 11th minus x to the 4th. Now let's see what f of negative x is. F of negative x means that wherever there's an x, I'm going to plug in what? A negative x. Now if I raise negative x to the 11th power, what am I going to get? Negative x to the 11th power. In other words, that doesn't change to a positive. But what do I get here? Positive x to the 4th, so that would be what? Positive x to the 4th? Will be negative. Hold on. I can see the negative. Okay, so this does not equal what? This. So let's check the last one. Negative f of x. So that means we're going to take a negative and put it in front of what? This right here. X to the 11th minus x to the 4th. And when you distribute this, what do you get? So what's our answer here? I don't see any of them matching, do you? This doesn't match this, so it's not reflective around the x-axis. And this almost matches this. But that positive is still in the way, so I would say it was neither. Is there neither? Yeah. I would say it's A. Let's check it and see. Unless we've done something wrong.
Why is that one not positive?
Which one?
The second one to the right.
This one?
Yeah.
All right, what is this? X to the 4th, right?
Right.
What's in front of it? A minus. Minus x to the 4th. It will catch you. That one caught me because I didn't even see it. We feel good about ourselves, so we don't have to put smokestacks on our trucks, especially a 4-banger. Okay? I know y'all ain't never seen anything like that. There was one part out here, right out here, in the faculty parking lot, where all the faculty parks, but in the student parking. It was a Ford Ranger. It looked like about a 1988 Ford Ranger, and it had smokestacks coming out of the back.
Two-wheel drive too, right?
Huh? Yeah, 2-wheel drive.
That was mine.
No, it wasn't. I was fixing to say, girls, if you run, 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 run. Fast as you can. Major issues. All right. 2.1, number 24. Determine the intervals where the function is increasing. Select the correct choice below if necessary, blah, blah, blah. Well, I'm just going to answer the question. I'm not going to go through and there's our graph. I can't get this out of the way, but it's not going to get out of the way, and I don't want to minimize it. Okay, that's good. All right. So, as I tell people, you can use a car, or you can use, where is my, oh, I can't, I wondered if it's still on pen. Put you a car here, or put you a plane. No, it's not on here. Big old space shuttle. All right? And as we take that space shuttle, and as we go this way to the next point, because the next point is right here. As we go in the X direction, because that's what we measured in miles, when you ride a plane or drive a plane or pilot a plane, whatever you want to call it, you don't measure your miles as vertical miles. You measure your miles as what? Horizontal miles. If you fly from here to Florida, you fly 452 miles, or whatever it is. You don't say, oh, well, we went 200 miles, we went up, and then 300 miles, we went down. That ain't the way it goes. So you always measure increasing and decreasing in linear values, which is X. So, what is the plane doing as it goes those first couple of clicks? It's increasing. So your increasing values, what's this arrowhead called right here? Negative infinity. Negative infinity to what? Negative 1. So increasing is from negative infinity, and they're going to put a parenthesis there, and we'll just do that to make them happy. Really, we're not getting into that again. And then he sees turbulence ahead. So the next couple of clicks, what does he do? He descends. So decreasing is from negative 1 to what? I can't tell. What is it? Positive 1? And then he decides, well, we're flying too low. We need to get up above the clouds again. And that does have an arrowhead on the end of it, so it's increasing from negative or from positive 1. From positive 1 to what? Infinity. Now, some of you may think this is very elementary, but I can guarantee you, $1 to a donut hole, somebody in here has never understood increasing and decreasing values until I put the plane on there. I guarantee it. You don't have to raise your hand, you don't have to say anything. So, don't judge. You may think it's simple. Just like when we get to completing the square, some of y'all are going to go, huh? Because you've never seen it before. Okay, so that's the answer. I'm not going to go through and punch it in, but that's the answer. Does it ask anything else? If it doesn't, we're just going to go on to the next question. No, Hubert, it doesn't say anything else. Okay, thank you, class. I'll just punch in a 3 and check because y'all are so interactive. Oh my God. I'm not going to say I picked these questions, but some of them were really redundant. Is my answers right so far? What's it asking now? Domain is all real numbers. How you put all real numbers? I'm not doing all that. I ain't doing that. 3, 8, whatever.
I don't know if you can do all real numbers.
On some questions you can. They tell you to put R. I don't know why they don't do it for all of them. Range. Oh, it didn't do the range. Range is from -1 to +1, right? No, I'm sorry. Negative infinity to positive infinity. Because it has what on the end of it? Arrowheads. Okay? So that's that one. (21) Determine whether the graph of the given function is symmetric with respect to x-axis with respect to... All right, we'll do this one. So plug it in, plug and chug. Check to see what f of negative x is and what negative f of x is. F of x is equal to x to the third minus x plus 2. F of negative x is equal to parentheses cubed minus parentheses plus 2. And that's a negative x there and a negative x there. So what do we get? Negative x cubed plus x plus 2. So let's circle that and circle this because those are the two we're going to compare. They're not equal, so we go to the next one. Negative f of x is equal to negative parentheses x cubed minus x plus 2. And what does that get us? Negative x cubed plus x, and they do not match either, so it's neither. But always go back and check your signs because sometimes you might make a mistake and it's just one little sign that causes it to be not correct. Okay? I know we're going backwards, but no, this is 57. No, it's 17. We are going backwards. So, don't matter. 17. Check to see if it's odd or even. So let's do it. Same thing we've been doing. F of x compared to f of negative x. So f of x is equal to x to the fourth minus 7x squared plus 8. F of negative x. F of negative x is equal to parentheses squared minus 7 times parentheses 4 plus 8. And that's a negative x there and a negative x there. And what will that yield? Well, this comes out to be x to the fourth. What does this come out to be? That is x squared minus 7x squared plus 8. So what does that tell us? Do they match? Or what does that tell us? They're even. Yes, sir.
How come it's 7x?
How come the 7x squared is at what? Okay, do parentheses first, next one's first. What is negative x, quantity squared? X squared. Okay? So it's even. What comes first in the alphabet? Even or odd? Even. E comes first. What do you check first? F of negative x is equal to f of x, or f of x is equal to negative f of x. you check that first. So that means if you get it, it's even. That's the way I always remembered it as a student. What comes second? Odd. Odd comes second. And that's when you say f of x is equal to negative f of x. But you don't have to check this one. Why? Because you've already got an answer. If it ain't broke, don't fix it. If you got an answer, don't go on to the next one because it's going to be useless. All right, next one. Next one is number 20. Yeah, I would use a calculator on this one. So get your graphing calculator out. Why? Because it's a decimal. Anytime you see a decimal in a quadratic and you can't change it to a whole number, then use your calculator because that's what calculators are for. Calculator is not to take the square root of 25 or to add 14 plus 7. So take your handy dandy calculator out, which I got to get mine, so just hold on a minute. Oops, is that the one we were doing? That ain't the one we were doing. There we go. Wait, hold on a second. Let me pull up the calculator. So y is equal to 0.5 x to the 8th. Somebody tell me what the x to the 8th does to this thing. Quartic. Anything above a quartic, what's it going to do to the bottom of the parabola? Make it square. Minus 2 x to the 4th plus 3. What's the y-intercept? 3. Good. Vertical shift is still 3. But that x to the 4th throws a hitch in it. Now, how do you see that? I always zoom window or zoom box. I don't use anything else. I use zoom out and zoom box. So you take your zoom out and you find your top left-hand corner, which would be right in here. Hit enter. Pull that box down and over so you can see the x-axis so you can count. There she is. That's called a saddle. What's it symmetric around? The y-axis. Now that's a question I would give you on a test as a gimme. Don't mess it up. I would give you a question like that, but I probably would. I might give you these, but there will be a couple of questions on there that I just want you to do on the calculator. Okay? And hopefully you feel good about yourself. So you don't have an orange face and a white neck when people call you an Oompa Loompa. That's for the girls. Guys, have you ever seen one of those? Run. Because they will take a bat to your headlights. Okay? Not that I know from experience, but I have friends that have done the Oompa Loompas and that just doesn't work. They're crazy. All right, this is 6. 2.1, number 6. You're getting a good class today. Didn't you say your questions were in 2.1?
Yes, sir.
You're getting a good class
Glad I
today.
came there.
Huh? Well, you got the video. Graph the function in standard viewing window, blah, blah, blah. You don't have to. X cubed, it's negative x cubed minus 1. Let's do this one on paper. So get your graph out again, the whole page. And I want you to graph x cubed first. X cubed. That's the one that looks like an S. I think it looks like an S. I can't remember how I drew it. Sometimes I get it mixed up myself. So let's take our handy dandy. right now I'm going to turn the grid back on. Well, I'll just go to the next one. And this is what your page should look like. I'd like to make those a little bit smaller. There we go. All right, sir. Let's take our orange. Turn, left it on orange. Need to make it a little bit bigger. Okay, so we're going to take our handy dandy pen now. Can't get this thing to stay on 4. And our parent graph is x cubed, right? So x, y, -2, -1, 0, 1, and 2. All right, what is -2 cubed? -8 cubed. Thank you, class. What's -1 cubed? 1. 0 cubed, I'll do that one for you. 0. 1 cubed is 1 and 2 cubed is 8. So let's graph that. -2, -8. -2, 1, 2, 3, 4, 5, 6, 7, 8. -1, -1. 0, 0, 1, 1, and 2 and 8. 2, 4, 6, 8. So our parent graph looks like that. Everybody with me? Now let's look back at the equation. First of all, write it in the right order. I don't know why this book does this. It irritates the crap out of me, but it is not in the right order. What do you need to write it in the order of? -x cubed. I think they do it just so y'all change it as practice. I don't know. -x cubed plus 1. So, there is no number inside this. So that means there is no what? Horizontal shift. That's right. So what does that mean this is? That's your vertical shift. But, what does this tell you? It's flipped. So let's go back to our handy dandy graph. So it's going to be flipped and 1 vertical shift. So I'm going to take my red marker. And this is where you don't have to plot the points. You just have to try to judge it. All right, here's my origin right now. Where is my origin going to be? Right here. Because I had a vertical shift before. Oh, wait, these are 0.5, so it would be, no, it ain't. I've counted them as 1 while ago. Okay, so there's my vertical shift. Now, instead of this thing looking like this, which way is it going to look? See how simple this stuff is? Now the sketch, remember, they don't care. I don't know if they're going to ask for a sketch or what. I don't know what they're going to ask for. But on a hard copy test, I would not ask you to plot that one. I would ask you just to sketch it. Because there's no need in you. I mean, you can go through and plug it in if you want to, but it's just a waste of time. Let's see. Okay, over the interval, what is it doing now? What is that red one doing? It's decreasing. If you put you a car right here, we read from left to right. Put you a little car right here. What is that car going to do?
Drop downhill.
going to go downhill, so it's decreasing. And you feel good about yourself. That's a gimme. Next one. I think this is the last one. Number 5. Determine the largest open interval of the domain over which the function shown in the graph below is A, increasing, decreasing, constant, then give the domain and range. All right, I'm just going to go ahead and just blow it up, and I'm not going to answer all this. I'm going to just do it all, and then y'all can figure it out. All right, so there it is. So, let's start with increasing and decreasing. We read from left to right, so it's decreasing from what? -5 to what? -5 to -2. Then it's constant from where? -2 to 3. Now see, this is where I disagree with it, because I think there should be a what here? A bracket. Now, what I want you to do on the homework, just make a mental note that should be a bracket. I don't know what they're going to ask for, because I don't agree with their questions, because on this part right here, do you use 2, -2? Yes. So that should be a bracket. But just make a note, because some of y'all have put brackets in and got it wrong. And I don't agree with that. This one gets parentheses because of what? Open circle. And this one starts at 3, decreasing, starts at 3. Bracket, I think there should be a bracket there. And it goes to what?
Real quick, for the first order pair, increasing, wouldn't that be?
Sorry, continue. You're right. Thank you. I just saw that. Yeah. That'd be negative infinity. You're right. Thank you. I just did that to make sure that y'all were paying attention. Negative infinity. Now, the domain and range for all 3 functions. The domain and range is all what? All real numbers. And you say, what do you mean? There's open circles there. Yeah, there's open circles there, but what are these? Closed circles. Are all the x values being used? Yes.
All the x values are.
Yes, all the x values are. No, yeah, the range is not, because you got a gap. Okay. The domain, all the x values are being used, even if you have an open circle, because this is being used here. Now, if it asks you for the domain of each section, then the domain of each section will be negative infinity to -2, bracket. Then from -2, open parenthesis to what? +3, parenthesis. And then from bracket 3 to infinity. It all depends on if they ask you if the whole thing as a whole or by section. I don't know what they're asking, so I'm just going to tell you the whole series, you know, from here to here, the domain is all real numbers. The range for the whole is equal to negative infinity to -2, negative infinity to -2, then from -1 to what? -1 to infinity. Now, if you ask for a breakup, the domain is broken up. The domain for the first part is negative infinity to -2. domain for the second part is from -2 to +3 with what? Parentheses. And then the domain of the third part is 3 to what? Infinity. Kind of like you're increasing and decreasing. Range for your first part is -1 to infinity. Big bracket. Range for your second part is what? 1. Big parentheses. The bracket goes on. And then the third part would be from -2 to infinity, negative infinity. So there's your possible answers of whatever they're asking for. We'll look and see what they're asking for, and I don't know. Oops, sorry. Let me get out of this. Close. The function is never increasing. Well, we decided that. The function is decreasing on the open intervals negative infinity to -2 and 3 to infinity. We did that. Over what open interval is it constant? We did that, -2 to 3. The domain is all real numbers. There's our range. So they did it as a whole. Okay? Don't like that one. I can tell you right now, I do not like piecewise functions. So, because it confuses students, and I don't like to put them. So if you get one from me, it's going to be one that's easy for you to understand. May not be easy for you to do, but it's easy for you to understand. Oh, this is so stupid. A teacher should not have logout time, especially if they use their email. But I'm the only one on campus that does it, so I'm in the minority. I'm the only one that videos the classes too, so maybe one day they'll catch up. Let's see. I just want to make sure I went over as many questions as I could today. Okay, that one, she's not here today, but that's 21. Okay, that's the one we just did. Okay, I don't see any more, so that's my 109. Okay, what is this? Is this 110? Oh, here's some. This is 2.5. Let's see what that is first before we move to it. I don't know if we're ready to go to 2.5 yet or not. No, that's piecewise. I hate piecewise functions. All right, we hadn't got there yet. All right, let me ask you this. I got two things to do. One is take the roll. Let me do that first, so y'all don't get a bunch of nasty emails. And then we'll talk about scheduling. Today's Wednesday. Yep. All right, Miss Black is here. Miss Bronner is here. Miss Carey, where are you? I'm trying to learn y'all's names. Miss Lovely is here. Miss Clayton is here. Mr. Cleveland, where are you? Okay. Cleveland. Mr. Craig. Miss Crip. Craig Crip. Crenshaw, what'd you do to your foot?
I rolled it.
Oh, I hate doing that. Did you sprain it? Blew up like a grapefruit? Yeah, mine does that all the time. I have very weak ankles. Fitzsimmons, okay. Frialdi is here, right? Guffey, Geimer. Holly is not here. She had to go to the doctor. Mickle is here. Richie is here. Ryder is here. I'm learning some of y'all's names. Savakul is here. Smith, where are you? Okay. Stolfus. I'm sorry. Stolfus. Vaughn and Vaughn. One and where's the other one? There you are. And vining, I'm learning some of y'all. Okay. We just went over 2.1 and we went over a couple of 2.2s. I'm going to take a look at something. You got 2 minutes, so some of y'all chill, okay? Y'all ain't got to go to a fire or anything.